Alright, so we're on to method 2, where we're solving quadratic equations, and this method is called factoring. We're solving by factoring, and we're going to use this method if there is a linear term. It's possible to factor. Not always, but a lot of times it is, and so we're going to figure out here how to do this. What we're going to do is take a look at two problems, I believe, and I found the two that I want to use here. This is perfect. All right, so let's go ahead and do this. The first problem is going to be, if my pen is working, here it is, 7x squared plus 41x equals 6. Now, we have to notice that in this problem we have a linear term as well as a quadratic term. The linear term, see if you can figure it out, is 41x, x to the first power. Linear, meaning that it would make a line if that's all we had was at 41x instead of the quadratic term. Oh, excuse me, I'm tired. Alright, so anyways, when we have this linear term here, we're going to try factoring. That's probably our first move. And when I'm factoring, I am going to get all my terms. I like to put them all on one side, and I like to use the left. It's just my way of doing it. You can put them all on the right if you want. But when I move that 6 over to the left, it has to change signs, because remember, I'm really subtracting it. We're kind of skipping a step there, since I think you guys can handle that. And there's nothing left on the right, so we're going to put a 0. Okay? Big thing that I want you to take care when you're doing this with, that didn't make any sense. Big thing I want you to be careful with is to make sure that you keep this x squared term positive. And you see how it's a positive 7? That's one of the reasons I didn't want to move it in the first place. So we're going to keep that positive. Now the other ones, I don't care if it's positive or negative, that's okay. I want this 7 though, or whatever it is, to be positive. Alright, so now I want to factor. So I look at my problem here and I see that other than 1, I don't have a GCF. So I am going to use the cheat method, and I'm going to do this in another color. We'll try pink. And I'm going to do this as scratch work off to the side, because this, remember, we're not doing the correct thing here, really. We're cheating to make this work for ourselves. So I'm going to multiply the 7 times the negative 6 and get negative 42. I'll show you what I was doing here. That right there, okay. Now I want to factor this trinomial. Notice I didn't put equals 0 or anything. I'm just factoring this right now. I look at my minus. That tells me I need one of each. X squared is x and x. And I need two numbers that multiply to give me this and add to give me this. And this is what everybody forgets. 42 and 1. If I multiply, I get negative 42. If I add, I get positive 41, so that's good. Now I have to remember to undo my cheating, so I'm going to divide by 7. Where did I get 7 at? From right here. That's what I multiplied by originally. Now I'm going to simplify. So I get the quantity x plus 6. 42 divided by 7 is 6. 1 over 7 does not reduce, so the 7 has to come up in front of the x. Swing it up like that. And now I'm set. Now I'm going to go back to my problem and fill in what I just accomplished here. X plus 6 and 7x minus 1. When you multiply them, you get 0. Alright, I'm going to erase this pink stuff because I'm running out of room. So I'm going to erase this. And you wouldn't want to erase it. You'd want to show that as your work. But like I said, I need more room. So from here I have two factors. I have x plus 6 and I have 7x minus 1. I'm going to set each factor equal to 0. And I'm going to solve those two equations to get two answers. So my first one, if I subtract 6 from both sides, x is negative 6. Or if I solve this one, I get 7x equals positive 1. I added 1 to both sides. And then if I divide by 7, I get 1 over 7. So my two answers are x equals negative 6 or x equals 1 over 7. I could always check. I could plug -6 back in here and here, and when I simplify the left, the right should equal 6, and I could plug in 1 over 7 both places, not just one place, both places. Have fun with that one, all those fractions, and you would get 6 on the right. So you could check to see that it worked correctly. Okay. Let me show you something here that you may come across. We'll leave this up here so you can use that as a reference for the time being. We'll use purple here now. We're going to use pink. I like pink. Let's say, look at this spot right here where we had these two quantities equal to 0 when they were multiplied together, right? Let's say we had the same thing, but we had, I'm randomly picking 7, could be any number, but we had a GCF that we pulled out first. And we had 7 times x plus 6 times 7x minus 1 equals 0. Now I have 3 factors, 1, 2, 3. If you set the first factor 7 equal to 0, that makes no sense, so don't do it. Just set the 2 that you can actually solve equal to 0. Alright, and when you do that, you're going to get the same 2 answers for this problem as you would for the blue problem. Okay, so just something to keep in mind. If you have that number out front because you factored it out earlier in the problem, don't worry about it. It's not equal to 0. We know that, so don't even bother with it. Alright, let's do one more here. This one's actually easier, but because it's easier, a lot of times people make this type of problem or this situation more difficult than it is, so I'm going to hopefully alleviate that. Alright, I can't use square roots because I have this linear term right here. It's probably making you dizzy me doing that. Ooh, we're going to go counterclockwise. Alright, so anyways, I want to get everything on one side, all my terms on one side, so I'm going to subtract the 12x. Notice that I didn't move the 10x. I didn't do this. I do not want to move the 10x over because that would make my quadratic term negative, and I do not want that. No good. So I'm going to move the 12x over and make it negative. Now from here I'm going to factor, and I see that I have a GCF. 2x can be factored out, and I'd be left with 5x minus 6 is equal to 0. So that's what I'd want to do right there. Now I have, you can think, there's different ways you can think about this, but I'm going to think about this as 2 factors. You can think of it as 3. You could think of it as, whoops, it's a bad way to do this, 2x in the quantity 5x minus 6. It's not going to make a difference. If we were to take 2x and set it equal to 0, and we divide both sides by 2, you're going to get x equals 0. Or we have 5x minus 6 equal to 0. And when we solve that, we'd add 6 to both sides and divide by 5, so we get positive 6 over 5. So my 2 answers will be x equals 0, or, looks like a negative sign, doesn't it? Or x equals 6 over 5. And I'm going to show you this over here because I know some people are scratching their heads saying, where did he get that? So look, slow motion. Add 6, so we get 5x equals 6. Divide by 5, and that's where the 6 over 5 is coming from. Okay? So that's what I did right there. So those are my 2 answers, and we are done with the factoring method.